Lesson 3.2, Patterns of Change in Linear Relationships. A constant is an unchanging thing, a number, with no variable, and it is always the same. A 3 is always a 3. A constant of change is also known as the rate of change, and we can also call this the slope. The constant of change is the value of the change occurring when the rate of change is constant or steady. So for example, if you turn on a faucet and you just leave the flow where you set it, the rate of change to the volume of water in a basin will be constant because the flow will be constant. However, if you're filling that same basin with rainfall, which changes in level of heaviness even through the same shower, the rate of change in the volume will change. Sometimes it will fill quickly, sometimes it'll fill slowly. It does not have a constant of change. Okay, determining the rate of a change, an associated equation, and the dependent and independent variables in a scenario. So let's say you're making cupcakes to sell for a fundraiser, and each batch will give you a profit of $11 for a school field trip. And how much money will be made off of one batch? Well, if we make one batch, we'll have an $11 profit. If we make 5 batches, well, 5 times 11 is $55 profit. If we make 10 batches, we'll have $110 of profit. So to write an equation relating the number of batches to the total amount raised, if we call y the total amount raised, and x is the number of batches, y is going to equal $11 times x, because we take the number of batches and we multiply it by 11 to get the total number. The dependent variable is the total amount of money raised. And the reason that is the dependent variable is because it depends on the number of batches that get sold. Dependent. So this is the number of batches. Okay, and 11 is the constant of change, because that is the rate that the total of money, amount of money, is being changed at. Okay, we have what's called a direct and inverse variation when we talk about a constant of change. So when a function has a constant of change and no constant, so for example, y is equal to 11x, but there's nothing being added or subtracted, the variables are said to vary directly. So if y was the amount of money raised and x is the number of batches that are sold, y varies directly with x by a factor of 11. And we wrote that as y is equal to 11x. And this is the basic form of a direct variation where k is the constant of change. An equation of this form, y equals kx, is a direct variation, because y varies directly with x. Every time you increase x, y increases. If you decrease x, y decreases. So here are some examples: 5x, 20x, 0.6x. Okay, the opposite function that can occur is if x and y vary inversely. And this is when k is being divided by x instead of multiplied by x. So the function would look like this: y is equal to k over x. Okay, so examples of an inverse variation. If we have an ice cream social and we have 20 gallons of ice cream, the amount of ice cream each person can have depends on the number of people that attend. If one person shows up, they could eat all 20 gallons. So if y is the amount of ice cream and x is the number of people, we want to write an equation that demonstrates that situation. You have 20 gallons and you divide it by the number of people that show up. This is an inverse variation. So we have inverse variation and we have direct variation. They look similar, but it's just a matter of where you place the x. Okay, there are three types of direct variation. As x increases, so does y. As x decreases, so does y. And as x increases, y decreases, or as x decreases, y increases. In the first two types, k will be positive. In type 3, k is negative. So for example, here we have a y equals kx situation where k is greater than 0. K is positive. And here we have y equals kx, where k is less than 0, so k is negative. And as you can see, if x goes up, so does y. If x goes down, so does y. So these are situations 1 and 2. Here we have as x goes up, y goes down, or as x goes down, y goes up. So this is situation 3. Okay, we need to be able to write and solve direct variation problems. So I have two examples. The pressure of a gas varies directly as the temperature. If the pressure is 12.5 at temperature of 250 K, that's Kelvin, what is the pressure at a temperature of 350 Kelvin? So first, we need to create the equation. Second, we need to solve for K. And then third, we need to find the new pressure. Okay, if we call pressure Y and temperature X, the equation is going to be Y is equal to KX. That's our first step. Next, we solve for K. I have a pressure of 12.5 is equal to K times X when X is 250. So to solve for this, I divide both sides by 250. And I get that K is equal to 0.05. So my new equation is Y is equal to 0.05x. Now to find our new pressure, we know that we want to find the pressure when X is 350. So we do 0.05 times 350. And we get that our pressure is 17.5 atmospheres. Okay, the price of tiling a room varies directly as the size of the room. So the price we'll call Y and the size we'll call X. Sam is laying tile in his kitchen. The tiling is $1,918 for 274 square feet. So we want to know what is the size of a kitchen that would cost $1,596. So our first step is to create the equation. Our second step is to solve for K. So I want to find out what is K when the cost is $19.18 and the size is 274. So I'll divide both sides by 274. And I'll get that K is equal to 7. So my equation is going to be Y is equal to 7x. Finally, I know that Y is equal to 7x. So I want to find out what is x when Y is 1596. So I'm going to divide both sides by 7. And I will get that that kitchen is 228 square feet. We can also solve direct variations with proportions. So if y varies directly as x and y is 18 when x is 5, find x when y is 90. This doesn't mean we don't have to find k. We put our first y over our first x is equal to our second y over our second x, or our first x over our first y is equal to our second x over our second y. It doesn't matter which way you do this so long as you have both y's on top or both x's on top. Okay, so what we'll do is we'll plug these in. Our first y is 18 and our first x is 5. Our second y is 90 and we don't know our second x. Now to solve for proportion, we cross multiply. So I do 18 times x and 5 times 90. And I get that 18x is equal to 450. Divide both sides by 18. And x is equal to 25. So let's try one more example. I have y is equal to 51.3 when x is 19, and I want to find y when x is 43. This time I'll put the x's on top. So I have 19 over 51.3 is equal to 43 over y. I'll cross multiply, and I will get that 19y is equal to 2205.9. Divide both sides by 19, and you get that y is equal to 116.1. Okay, we have two more examples. Just as we can solve one of the problems we just did with proportion, we can also solve one of these word problems with the proportion instead of solving for the constant k as we had done before. So if we look at this, we have the number of calories needed in a daily diet varies directly as the weight of an individual. So if we call the number of calories y and the weight x, we have 1,550 calories should be consumed daily for a 155-pound person. So I call this y1 and x1. What is the weight of an individual who consumes 1,790? So this would be y2, and we don't know x2. So setting that up, I get x1 over y1 is equal to x2 over y2. So I put 155 pounds over 1,550 calories is equal to some unknown x over 1,790 calories. And again, cross multiply. And I get 1,550x is equal to 277,450. Divide both sides by 1,550. And x is equal to 179 pounds. In this next example, we have the number of wrecks at a certain intersection varies directly as the number of cars. So wrecks will be y, cars will be x. If we have 17 wrecks when 833 cars have passed through, and we want to know how many cars have passed through after 6 wrecks. So we have 6 wrecks over some unknown number of cars. We'll cross multiply again. And I have that 17x is equal to 833 times 6, which is 4,998, Divide both sides by 17. And x is equal to 294 cars.